Great, thank you, Wendy. Hello, everyone. Thank you for joining our webinar today. My name is Tasos Mikhail. I'm a Senior Product Manager in the Prisma SD WAN team. And I'll give you a quick introduction to Prisma SD WAN, and then going to some more specific topics that we showed in the agenda. So let me start by just highlighting some of the key principles and key differentiators of Prisma SD WAN. So Prisma SD WAN is a key pillar of Prisma SASE by Palo Alto Networks, and it's also the industry's first next generation SD WAN product. On this slide, you see like three areas, three key architectural principles of the solution. So first of all, Prisma SD WAN is application defined. So as a solution, it can do deep visibility, policy and traffic steering decisions at layer 7 and not just at layer 3. It's a completely autonomous system. We're using machine learning and AI methodologies for both troubleshooting, but also for configuration. And it actually provides a cloud-delivered branch through a cloud-managed platform, which is fully multi-tenancy and microservices based. And we're going to go into more details on these three areas. And you can take advantage of all of our innovations without really having to upgrade all of the infrastructure elements in the cloud. At a high level, the Prisma SD WAN solution consists of ION appliances, which are, we offer a number of physical and virtual SD WAN appliances that can be deployed at different types of branch offices, retail stores, ATMs, and so on, or can be deployed as data centers. All the ION appliances are managed through a cloud management platform, the Prisma SD WAN Cloud Controller, which is also fully integrated with our Prisma SASE Cloud Manager, and can be fully integrated with Prisma Access, our cloud-delivered security solution by Palo Alto Networks, to provide the full SASE experience to customers. So as a solution, Prisma SD WAN provides like a fully integrated network and security as a service with the best-in-class security capabilities coming from Prisma Access. So let's go into a little bit more detail on these three areas. So first of all, compared to other solutions, Prisma SD WAN has the ability to perform deep visibility at layer 7, identify and understand different types of applications and different applications, and then apply policy and traffic steering decisions at layer based on layer 7 information, layer 7 insights, and not just layer 3. So we have the ability to look at performance insights for every application, also for every available path. So with hybrid work, as a lot of employees are switching between working from home and working from an office, or also working from a public space. Oftentimes, administrators have to actually look and identify a problem. And sometimes the issue is like they don't have the deep visibility and the metrics that can actually detect whether the problem is because of an application performance, a network issue, or something in the cloud. This combined with the fact that most of the applications used by enterprises today are cloud delivered, makes it complicated for troubleshooting. So with layer 7 visibility, network administrators have the ability to look at the entire path of delivery for an application, and then identify where problems are by looking at segment by segment insights. Through our dashboards, they can also see the usage by, the bandwidth usage by different types of applications, the bandwidth utilization at the site level, and also, they have the ability to also rank applications based on, user experience score, remote site experience score, and so on. The second key fundamental principle of Prisma SD WAN is that it is autonomous, so which helps simplify network operations. Network administrators, in order to troubleshoot and identify network issues, oftentimes they actually have to analyze multiple dashboards and correlate issues from different platforms, which increases time to resolution. With the network insights provided by Prisma SD WAN, you can actually look at circuit health metrics and very granular site-specific insights to understand and proactively identify issues and apply smarter network policies throughout your SD-WAN network. Prisma SD-WAN also provides policy control on event correlation and analysis for greater control over events that are which generated on with automatic prioritization. So we can do event correlation, and instead of presenting a number of events or a number of alarms, we actually do aggregation to determine the root cause and again provide actually easier time to resolution, which helps actually with troubleshooting tickets and reducing the time to addressing issues. And then the third area that I mentioned in the first slide is cloud delivered branch. For those who may not be familiar with our CloudBlades feature, so CloudBlade essentially is an extensible API-based platform for integrating different types of third-party services. It allows for seamless integration of branch services with zero service disruption. Such services, as you see here on the slide, could be multi-cloud integrations. So for example, AWS, GCP, or Azure. Could be collaboration apps such as Zoom or Microsoft Teams. So the ability to actually integrate with, from every branch side to different types of collaboration apps, both for providing, deep visibility and insights on the performance of the app, but also for automating different tasks to simplify operations. And then another area is applications and services such as ServiceNow for automating operations, where you can actually, with CloudBlades, perform the very seamless integration for ticket creation and management in a very simple way. CloudBlades essentially are independent containers that can be upgraded without impacting the controller operation or the branch operation. So there's no impact on service. And as an enterprise adding more sites and expanding their network, new branches can be automatically integrated with these third-party services without actually impacting the service in existing part of the network. So, and then, the other thing that's important to highlight here is that Prisma SD WAN is natively integrated with Prisma Access, our cloud delivered security. So combining the two products essentially provide the best-in-class security to branches delivering through the cloud and eliminating the vast majority of web-based threats with machine learning, threat protection, and other technologies. So combine the two products, deliver an exceptional end user experience with app SLAs. And here in this slide, you can see how an enterprise or a customer can actually fully integrate Prisma SD WAN sites through Prisma Access locations and points of presence to provide like an end-to-end full SASE experience and deliver the best-in-class security from the cloud. Now I'm going to close this introduction by just summarizing that Prisma SD WAN includes an extensive set of ION appliances to enable zero-touch provisioning and delivery of SD-WAN services. In this slide, you can see some of our existing products that and their capabilities. ranging from the ION 1000 all the way to the ION 9000. And depending on the type of deployment, the type of office, and the performance requirements and the number of employees, you can select the right appliance, for the deployment. And we do offer also virtual models, the VIONs, that can be deployed as branches or as data centers in public cloud or kind of universal CPE platforms. So with that, I'm going to actually move to show you what's typically the first thing that happens once you purchase an SD-WAN set of appliances and SD-WAN servers from Palo Alto Networks, and what the service activation looks like. So, we've recently actually introduced a number of innovations in how service activation takes place. So at the high level, if you look at this slide, the high level flow is that once an order is placed and the product ships, you typically would receive an email. It typically gets sent to the administrator whose contact information is in the purchase order. And that includes what we call a magic link. So that link is what you need for activating the service. So typically what you do is you open that email, you'll see what product and what licenses and quantities you've purchased, and then you click on that link, and then it will take you actually to a screen to create a user ID and a password. Now, if you're an existing Prisma Access or Prisma SD-WAN user, you'll typically have an email and a password set up, so you can just use those for login, and then you'll just move to the SASE portal screen where you're ready for service activation. So here I'm going to actually walk through two simple examples. The first one is a standalone SD-WAN new license activation. And then the second one will actually show you how you activate SD-WAN as an add-on to Prisma Access. So once you actually click on that email that I showed you earlier and log into the SASE portal, you'll actually be taken to what we call the common services screen. So the common services screen the first tab will be give you a view of your subscriptions and add-on services that you have already claimed and activated, or the ones that are unclaimed and ready to be activated. So in this particular example, we're showing a Prisma SASE subscription, which includes 2 physical IONs and 3 virtual IONs from Prisma SD-WAN. So what you do is you click on the claim button, and then you have to actually select the customer support account and select a parent tenant. Now, the process is pretty much the same, whether you're actually setting this up as a multi-tenant hierarchy or as a single tenant. So by, this new activation process, we're kind of streamlining the steps, and you have the flexibility to, set up multi-tenancy or just activate as a single tenant. So here, what you do is you actually, once you select the customer support account, you select, or you can create a new tenant if one doesn't exist. So here we're going to select the activation demo parent, and then we're going to click claim and continue. And then the next thing is you're going to actually see here, the summary screen. So you'll see the tenant ID, and then you can actually click here on add licensed product to activate the SD-WAN against this parent tenant. The next thing you have to do is actually select the region where you're going to be storing all your stats and data for that particular tenant. So you click on the region. In this case, we're going to select United States. And then the next thing is here you would see what products are ready for activation. So in this particular case, we're activating Prisma SD-WAN. So this has to be selected. You need to agree to the terms and conditions, and then you click on Activate Now. So you'll see here on the top that the licensed product is Prisma SD-WAN, and it's going through initialization. Here, actually, you can see your tenant ID, and here you can see the region that you selected. And then few seconds later, you'll see that the screen refreshed to complete, and that's it pretty much. Now your SD-WAN service has been activated. And later on in the presentation, Richard will actually go into more details on how you configure and deploy sites. Now, before I hand it over to Richard for that, let me also show you a very quick example of how you can actually activate SD-WAN as an add-on to Prisma Access. So for customers who already are using our Prisma Access solutions and they want to introduce SD-WAN, the activation flow is pretty simple. So here, you'll see a view of the common services screen. Again, I'm not going through the initial steps of clicking on the magic link, but here you see that as a customer, you've already activated Prisma Access Enterprise license and some of the add-on features like Autonomous DEN, DLP inline, and SASE security inline. So all you have to do here is you want to select Activate SD-WAN. You'll see here that you've purchased a quantity of 20 branches and 4 DC licenses and DVR as an add-on. So you click on Activate. You'll be taken to a screen which shows the CSP account and the tenant name. You already have the CSP account and the tenant name because you already have Prisma Access activated. And then, you agree on the terms and conditions. You click on Activate Now. You will go through an activating screen, and then it's activated. So you'll see that Prisma SD-WAN is also activated along with Prisma Access. So these are the 2 examples I want to show you. And if you have more questions on this topic, we're happy to answer them in the chat or following up from the webinar. So with that, I'm going to hand it over to Richard, who's going to walk you through the rest of the topics.
Thanks, Douglas. Okay, so we're going to start with a high-level architecture of the Prisma SD-WAN solution. So there's 3 main components to the SD-WAN solution. So we have the Prisma SASE or Prisma SD-WAN cloud management solution, which has us just showed the activation for. And then we have the SD-WAN branch appliances on the left-hand side. And then on the bottom right-hand side, we have the SD-WAN data center appliances. So these 3 components can build our application fabric. So the SD-WAN devices are carrier agnostic. So essentially we can connect to your data centers or to your cloud services by any type of media, could be internet, MPLS, LTE, additionally VPLS, any private L2 links you may have. And all of these together build the application fabric. So the application fabric, it encompasses your entire network, its configuration, provisioning, management, and monitoring. So the SD-WAN devices, they communicate to the controller over a bidirectional authenticated SSL connection. And they automatically establish VPN connectivity between the branch and data center devices. So when you bring a branch device up, it will automatically build VPNs to the data center devices. So by default, we're going to deploy a hub and spoke model where all branch devices will connect to all of your data center appliances. Additionally, we can support full or partial mesh depending on the business requirements. So if we look at the controller architecture, so the SD-WAN controller architecture is built on multi-tenancy capabilities from day one. So this provides service isolation for all of the individual tenants within each of the controllers. So currently we have 3 controllers which are spread geographically, and depending on where the majority of your devices are located, you'll be assigned to the appropriate region. And then within each of those controllers, each customer tenant is fully isolated from every other tenant. So configurations, policies, analytics are all separate from every other tenant. You can check the status of any of our controllers using this link here. This will show you any of the uptime issues. It will also show you information on upcoming scheduled maintenances. Okay, so all of the security and network connectivity policies are managed by the central controller. And one other key thing is that the data plane is completely isolated from the controller. So at no point does any of the data traffic between any of the ions which are communicating with each other ever pass to the controller. So they operate independently. They operate based on the policies that have been configured and provisioned to them. They will then make the appropriate policy and path decisions based on the policies that have been configured. So this centralized controller gives us the ability to authorize or revoke devices from the customer's network. But it's also key to remember that the controller itself is not critical to the day-to-day running of the ION devices. If there were to be an event where the branch device or data center device was disconnected from the controller temporarily, this does not impact the data plane of the device. So it will continue forwarding traffic based on the policies that are configured whilst the controller connectivity is down. As soon as it comes back up, it will receive any updates that it needs. So the IONs themselves will communicate with the controller over these TLS sessions. They use that for a multitude of different functions, for receiving configurations, and also for sending analytics data back up to the controller, where you can review for any analysis that you need. So we have something called authorized chain of trust. So when an ION is purchased, prior to shipping to the customer, a device has a specific certificate installed into it. It's called a MIC or a MIC, which is a manufacturer installed certificate. So once the device is received, you can plug the device into your network, and through zero-touch provisioning, the device will connect to the cloud controller. But at that point, the device is unclaimed and it's untrusted, and is essentially in a kind of quarantine state. So once the device has been connected, it will establish a secure connection to the cloud controller. And then there will be manual authorization from a user. So this can be done from the Cloud SASE portal or via APIs. And this allows the users to authorize the device to come into the network. So once the authorization has been given for the device, the controller will generate a device-specific ID for that particular device, and then generate a CIC, a customer installed certificate. So this CIC is then communicated to the SD-WAN appliance, and then the SD-WAN appliance will then reinitiate the connection to the controller with this new certificate installed. So at this point, the device still can't fully operate on the network. So once the device has been claimed, in order to be fully operational, the device then has to be assigned to a site and have the appropriate configurations and policies applied to it. At which point, the device can be put into service, and the branch or data center device will be part of the application fabric. So once the device is claimed, the IONs will start building the VPN tunnels over the internet or MPLS connections to the data center devices. So the controller will send VPN keys to the branch devices and to the data center devices, and each ION will have enough keys to fully operate independently for 3 days. So they're installed in the ION, and so if there were to be lack of connectivity to the controller, this will allow the devices to operate independently for up to 72 hours. So the ION endpoints, they renegotiate session keys every hour, and each session key is independent per VPN. If you just look at the connections that the ION devices have towards the cloud controller, there are 4 connections from each ION to the cloud controller. So we have one for communications, for configuration and state. This is called MRL. We have another connection between the branch device and the cloud controller, which is for flows and statistics. So all of the analytics data, all of the flow information for each of the sessions that run through the branch device will be transmitted up to the controller, where it can be viewed for analytics. Also, logs and alarms and alerts will also be sent to the cloud controller. We also have an optional connection, which allows us to have inbound connectivity to the devices from the cloud controller. So if you ever have to connect to the device for the CLI, you don't actually have to open a terminal, create an SSH session, and SSH to the device. Inside the UI, we have the ability to create remote access sessions, which use SSH-like UI, but over a secure TLS session to the remote device. And then just to quickly touch on software and upgrades. So this is split into two components. So we have the controller software. So this is managed and maintained by Palo Alto Networks. The upgrades to the controller are done approximately every 3 months. So we do this to either introduce new features or address any known issues. The upgrades themselves will be scheduled in advance, and you will have notifications in your portal or via the status page that I showed earlier to indicate when the upgrades will happen. The key thing to note here is that during the upgrade of the controller itself, the ION data plane functions are not impacted at all. So the management portal will be unavailable, either for users to log into the portal or the APIs, if you're using APIs to access the portal, but those will be down during the maintenance, but it doesn't impact the functionality of the end devices. And then the other type of software is the element software, which is for the IONs themselves. And so this is customer managed. So it will be released by Palo Alto approximately every 1 to 2 months per release branch that we have. And these will, again, either to be to introduce new features or to address any known issues. And then the software updates are pushed to the portal, and then you have the choice of which devices and when you want to upgrade them. So you can upgrade devices on the fly. You select a device, you would like to upgrade it, you can upgrade it instantly, or you can schedule devices to be upgraded in advance. So if you have a window at 2 o'clock in the morning, and you want to upgrade 20 devices, you can schedule those devices to be upgraded to the appropriate software release at Tuesday at 2 o'clock in the morning. And software releases are selected based on feature requirements. So we have different branches of code which have different feature support. So all of the feature support can be found in our release notes. Okay, so we're just going to run through a very simple site and device setup. So just kind of a prerequisite for this, we're making some assumptions that the ION has been connected to the network, meaning that it's been plugged into some kind of internet or LAN connection at the branch and has, with zero-touch provisioning, connected to the cloud controller. We're also going to assume that the device has been claimed. I talked through the claim process a little bit earlier, and that the device has been upgraded to the appropriate software release that has been desired for this site. So in the Prisma SD WAN portal, under Manage, we're going to go to the Sites page. In the top right-hand corner, we're going to have an Add Site button. So we're going to click on that, and that's going to take us through the site creation workflow. The first screen you're going to get to is just some basic information about the site. We're going to give it a site name, and then we're going to put the address details in. So in the bottom left-hand side, we have an address search bar. It's preferred to use this method. So you're going to put in the street address of where the branch is located, and then it will auto-populate the address field on the right-hand side. So using the search field also will input the longitude and latitude automatically for you, allowing it to be viewed in the topology screen in the SD-WAN portal, so you can see where all of your devices are geographically. So next, we're going to select the type of site that we're deploying. So as I mentioned, we have 2 types of sites. We have branch sites and DC sites. So in this site, we are going to select a branch site. And then we're going to select the policies. So there are 4 types of policies that are available for a particular site. We have path policies, QS policies, security policies, and NAT policies. Of these policies, the 3 mandatory ones are path, QS, and NAT. Security policy is optional, but recommended. So once you select the policies, you move on to the next screen. And here we're going to select the circuits. So we have 2 types of circuits that we can configure in our SD-WAN site. We have internet circuits, which is fairly self-explanatory. These are internet circuits, and then private WAN circuits. So private WAN circuits could be MPLS, VPLS, some other private connection that you may have. So under the internet circuit here, we're going to select the type of handoff that we have. So it's an internet in this case, and then the provider that is giving us that handoff. There's also some additional configuration you can add, which is to do with the bandwidth for the site, where the QS is going to be enabled or not, etc. So once you've done that, you get delivered a summary screen. So this just shows us everything that we've seen on the previous screens. And then you're going to hit save and exit on the top right-hand side. At that point, your site has been built. So the site has been built, but we don't have any devices assigned to the site. So what we're going to do is we're going to go to the site summary screen. And again, you can see everything that we configured previously. And then in the middle of the screen, we have an assign device button. So we're going to click on the assign devices. And then in this next screen, you'll see a list of all the available devices. So you'll use the serial number, typically, of the ION or IONs that you're selecting for this site. Select the ION, and then this will attach the ION to the site. So once the ION has been attached to the site, this allows us then to go in and configure the various components for the SD-WAN device. So on the first screen, we have the basic info tab. This is where we give the device a name so that you can easily recognize it, and then allows us to configure the forwarding modes. Typically, most deployments now are going to be using L3 forwarding mode, so we need to ensure that those two L3 toggles are enabled. And then we're going to go on to configure the interfaces. So we have different interface types. There are controller interfaces, there are WAN interfaces, and LAN interfaces. So in this case, this is the configuration for a typical internet port. We have the use this port for selected for internet. So this denotes that this port will be used for internet. When the device is configured for internet, we automatically apply a firewall policy to this internet interface, which will block all inbound communications, barring VPN tunnel traffic. So just UDP 500, 4500, and ESP. Everything else is blocked by default. We're also going to attach a circuit label to it. This circuit label comes from the circuit configuration that we configured when we originally configured the site. And then we're going to give it an IP address. In this case, I have a static IP configuration, but if the handoff from the carrier is DHCP, then you can also take the DHCP address. So you're going to go through, you're going to configure the different ports that we have. Here we have one controller port, we have one internet port, and we have one LAN port. And then there are additional things that you can configure based on the requirements for the site. So there's routing, could be static or BGP, and then management features that we have, so SNMP, syslog, NTP, IP6 for NetFlow export, and any DNS service profiles that you would want to apply to it. So once the device has been configured, the next step is to put the device into control mode. So going back to the main site screen, we're going to select the mode here, and then we're going to put it into control mode. So once it's in control mode, the device will start establishing VPN connections between itself and the data center sites. And then at which point you can then complete your change, do any cable swaps you need to do, and put the device in service. Okay, so we're going to talk a little bit about the policy model. It's going to be very high level. The next SD-WAN focus session that we have will go into a lot more depth about the SD-WAN policies. So one of the key kind of tenets is configuration abstraction. So the goal of the SD-WAN solution is to provide a level of configuration abstraction that allows you to create a given configuration element once, and then use it across multiple devices within the site. So the configurations, they're abstracted at either a global or site-based level. It allows you to essentially configure your policies that are site or device specific without actually having those sites or devices built. So we can pre-build all of the policies, and then when the sites are deployed, we apply these policies to the site. So the configuration is abstracted through multiple policy modules, application definitions, and prefix filters. And these modules can be thought to be kind of interchangeable building blocks that you can reuse across your enterprise. So this greatly simplifies the configuration and the operational burden compared to other methods. So with this model, we can, we can abstract about 90% of the configuration away from the device. If you look at traditional deployment models where you have to configure device-specific policies on each of the devices. So we have a central policy and configuration and control. So all of the policies are defined on the controller. So there are no device-specific configurations that need to be done. You don't need to log into a device to configure a policy. Everything is done within the portal. You build the configurations, and then you bind these policies to the site. So as I mentioned earlier, each branch site, it must have a path policy, a NAT policy, and a QoS policy. Again, optionally, you can configure a security policy for each of the sites, and this is highly recommended. So yeah, you can build your policies based on your business intent and your network and security requirements, and these policies can be modified or cloned and applied to different sites based on the business requirements. So we have two types of policies, or two types of ways to view the policies within the SD-WAN portal. We have what we refer to as a simple policy stack and an advanced policy stack. So simple policy stack is just a collection of policy rules in a single policy set. It allows you to have essentially a single pane of glass to view all the policies for a specific site. So this simple stack emerges two types of policies in the background, a default policy set and an individual policy rules, and they're all viewed in one single screen. So for a simple path or QoS stack, a minimum it's going to have two pre-configured default rules. So we have a default rule, which is essentially the rule that will match all of your unknown destination traffic bound for the internet. You can think of this as your kind of quad zero rule in a traditional router. And then we have an enterprise default rule, which matches all of your enterprise specific prefixes. So typically this is going to be your RFC 1918 addresses, your 10.x, 172.16x, and then 192.168x traffic. If you do have public address space that you use within your enterprise, then you can also map your public address space to this enterprise default rule, so that any traffic that is destined to this public address space is treated as enterprise traffic instead. And then we have advanced path and QoS stacks. So this is for more complex deployments where you may have some DO policies. Maybe you want to apply certain sort of default behaviors for all of your branches, but in maybe, let's say, in EMEA or the US, you want to have different behaviors for certain applications. This allows you to stack multiple policies together to provide kind of more granular level. So you can stack up to 4 policies together with one default policy rule set as well. And all of these policies are modifiable on the fly. So if you have a new application defined and you want to build a new policy for that particular application, we're just going to go into the appropriate policy set where we want to add the rule. We're going to add the rule, and then the policy will be immediately pushed down to the devices. So finally, we're just going to touch on the RMA process. So not that it happens all the time, but it is inevitable that occasionally a device may have some issues and needs to be replaced. So we want to keep things as simple and as easy for customers as possible in order to complete the RMAs. So we're just going to walk through what the RMA process looks like. So before we actually get into what an RMA looks like, you're going to go through the typical support methodology, opening a service ticket with the support team. They will troubleshoot the issue if need be, and if it's determined that an RMA is required, then we will ship the appropriate device to the site. So once we have the device at the site, we're going to run through what the RMA looks like. So in this example here, we have the Raleigh branch here, and we're going to replace this device. So before the device can be swapped out with a new one, there's some prerequisites that have to be in place. So the new device has to be online, so meaning that the device has been connected to the network somehow, could be via an internet connection or via a local LAN connection, and has some connectivity to the cloud controller. So this device has to be online. It then has to be claimed, and then it has to be upgraded to the appropriate software version as a faulty device. So in this case, we have 561D10. So the new device that we're going to use to swap this out with needs to be upgraded to that appropriate software version as well. And then once all of those prerequisites are in place, you can select the device you want to replace, and then using the sub-menu on the right-hand side, you can select replace this device. So this is now going to bring up a pop-up screen, and it's going to show you all of the devices that are compatible with this device that you want to replace. So you're going to see devices that are of the same model of the device that we want to replace, and that are claimed and that have the appropriate image version. So you can see here that this device has the same 561D10 image that the device you want to replace has or had. So you're going to select the appropriate serial number based on the device that was shipped to you and select that device. And then you're going to set the device, and then you're going to confirm that you want to move ahead with the next steps. So what's going to happen is the controller is going to take a snapshot of the configuration, so we know what to apply to the new device. Optionally, you can, at this point, through the RMA wizard, you can download a snapshot if you want to for archiving purposes. Then you're going to select next, and then here it's going to assign the device. So what it's going to do, it's going to take the old device that was faulty. It's going to remove that device from the site. It's then going to attach the new replacement device to the site. And then once it's been assigned to the site, it's then going to go and push the configuration to the new device. So once that's been done, the device will be fully operational, and it will have all the same configuration that the faulty device had. And so at no point did you ever have to console into the device and configure anything. We did this all through the UI just with a few clicks, showing how easy a replacement would be. So now you can see the Raleigh Ion 2K at the bottom is green, the assigned one is online, and then you can see the other Raleigh Ion 2K, which is now claimed but is in the offline state. So just a few final steps is that we're going to put this device back into the inventory. So from the sub-menu on the right-hand side, we're going to select the offline device, and we're going to put that back into inventory. And then you're going to move from the claimed devices screen over to the unclaimed devices screen, and we're going to initiate the return to Palo Alto support. So this means that once the device has been received by Palo Alto, we will then remove this device from your tenant. And that's all I had. Thank you very much.